Last time we learned about lists, how they let us store multiple values in a single variable and easily add, remove, or modify elements. Today we're going to look at something that looks very similar to a list, but behaves a bit differently: the tuple. Like lists, tuples also allow us to group multiple values together. But there's one key difference. Tuples cannot be changed once created. That means they're ordered. Each item has a fixed position, and unchangeable, or what we call immutable. Tuples are written using round brackets, unlike lists, which use square brackets. For example, here we have two variables. My underscore tuple uses parentheses, while my underscore list uses brackets. Both hold the same values, but my underscore tuple cannot be modified. You can't add, remove, or change elements in it. Finally, just like lists, tuples can also hold mixed data types: numbers, strings, or even other tuples altogether. Just like lists, tuples are ordered collections, which means the items keep the same sequence in which they were added. However, unlike lists, tuples are unchangeable. Once a tuple is created, its contents cannot be modified. Tuples also allow duplicate values, just like lists. If the same element appears more than once, Python keeps all of them, because both order and repetition matter in tuples. Tuples are also indexed, meaning each element has a specific position. The first item is at index 0, the second at index 1, and so on. Even though tuples are immutable, you can still access elements by their index and read their values. You just can't change them. So when we compare tuples to lists, the key difference becomes clear. Lists are ordered and changeable, while tuples are ordered but unchangeable. Let's look at how tuples and lists compare side by side. Both are ordered collections, but the key difference is mutability. A list is mutable, meaning you can add, remove, or modify its elements after it's created. A tuple, on the other hand, is immutable. Once defined, it cannot be changed. Because tuples are fixed in size and content, Python can store them more efficiently. That's why tuples are faster to process than lists, especially when dealing with large amounts of data that don't need to change. So the rule of thumb is simple. Use lists when your data will change, and use tuples when your data is constant or should remain protected from modification. Here's how a tuple is created in Python. In this example, the variable colors stores a tuple that contains several different types of data: strings, numbers, a Boolean value, and even another tuple. Notice that we use parentheses to define a tuple, and each item inside is separated by a comma. One important thing to point out is that tuples can store mixed data types. That means you can combine text, numbers, and other objects all in one tuple. You can even nest a tuple inside another tuple, like we see here with 1, 2, 3 at the end. This example shows that tuples are flexible in what they can hold. The key limitation is that you can't change them after creation. Let's look at this example. In Python, line 1 creates a tuple. If we print it, Python will display parentheses 1, 2, 3 parentheses. So technically, this works. However, try not to write tuples this way. Always use parentheses when creating tuples. Why am I saying that if the code works? Because parentheses make your code clear and readable. Especially if someone on your team is new to Python, a line like this can create unnecessary confusion. By omitting two parentheses, you are not saving any meaningful time, but you are reducing clarity. So even though writing numbers equals 1, 2, 3 works, the best practice is to always write tuples using parentheses. I know that not every Python programmer will agree on this, but remember, readability is critically important. There is no reason to introduce unnecessary confusion into your code. Here's something that often confuses beginners when creating a tuple with a single value. In this example, variable underscore 1 is written as open parenthesis 5, close parenthesis. It looks like a tuple, but it is actually just an integer. Why? Because in Python, parentheses are commonly used for grouping expressions. When Python sees open parenthesis 5 close parenthesis, it evaluates it exactly the same as just 5. Since there is no comma, Python does not recognize it as a tuple. The parentheses simply group the value. They do not create a tuple. Now look at variable _2. It is written as open parenthesis 5 comma close parenthesis. Notice the comma after the value. That comma is what makes it a tuple with one element. In Python, tuples are created by commas, not by parentheses. This can feel a bit confusing at first, but it is an important concept to understand. If you print the types, you will see that variable _1 is class int, while variable _2 is class tuple. Why is it designed this way? Because a tuple is defined as a sequence of values separated by commas. In the single element case, without a comma, Python has no way to distinguish between a grouped expression and a sequence. The comma signals that you are defining a sequence, even if it contains only one item. So here is the key takeaway. When creating a single element tuple, always include a trailing comma. That comma makes all the difference. You can also create an empty tuple, which is simply a tuple with no elements in it. In this example, the variable empty is assigned to a pair of parentheses with nothing inside. This creates a valid tuple object, just one that happens to contain 0 items. Empty tuples are sometimes used as placeholders in programs. For example, when you want to initialize a variable that will later hold tuple data, or when a function needs to return an empty result. So, empty equals open parenthesis, close parenthesis, defines a tuple that exists but has no elements inside. Even though tuples are immutable, meaning we can't change them, we can still access their elements just like we do with lists. In this example, the tuple fruits contains 3 items: apple, banana, and cherry. The first line, print fruits 0, accesses the first element. Remember, indexing starts at 0, so this prints apple. Next, we have fruits -1, which uses a negative index. A negative index starts counting from the end of the tuple, so -1 refers to the last element, in this case cherry. The last line, fruits, open bracket 1:3 close bracket, shows something called index slicing, which lets us access a range of elements. We'll come back to slicing later in more detail, but for now, just know that it allows us to extract part of a tuple without changing it. So even though tuples are unchangeable, they are still indexable and sliceable, just like lists. Here we can clearly see the difference between a list and a tuple when it comes to mutability. At the top, we have 2 variables, my underscore tuple and my underscore list. They look almost identical, but the first one uses parentheses, so it's a tuple, and the second one uses square brackets, so it's a list. When we try to change the first element of the list using my underscore list open bracket 0, close bracket equals 100, Python allows it. The list is mutable, meaning it can be modified after creation. But when we try to do the same with the tuple using my underscore tuple open bracket 0, close bracket equals 100, Python will raise an error. That's because tuples are immutable. Once they're created, their contents cannot be changed. So if you ever see an error like type error, tuple object does not support item assignment, it's Python's way of reminding you that tuples are read-only collections. Even though tuples are immutable, meaning we can't change their contents, we can still perform several useful operations with them. Here we have 2 tuples. A equals open parenthesis 1,2, close parenthesis, and B equals open parenthesis 3,4, close parenthesis. The first operation, A plus B, concatenates the 2 tuples, producing a new tuple, 1, 2, 3, 4. Notice that this doesn't modify A or B. It simply creates a brand new tuple combining both. Next, A*3 repeats the tuple 3 times, resulting in 1, 2, 1, 2, 1, 2. This is similar to multiplying a string by a number in Python. Len, open parenthesis, a close parenthesis, gives the length of the tuple, in this case, 2 elements. Finally, the expression 3 in B checks for membership. It asks whether the value 3 exists inside tuple B. Since it does, the result is true. So even though tuples can't be modified, we can still combine, repeat, measure, and search them, all without changing the original data. At first glance, it looks like we're adding new elements to a tuple here, but that's not actually what's happening. In this example, tuple 1 starts as 1, 2, 3. Then we use the plus equals operator with another tuple, 4, 5. Even though it seems like we're appending to the existing tuple, Python is actually creating a brand new tuple behind the scenes. The new tuple combines the two and reassigns the result back to the same variable name, tuple 1. This doesn't violate immutability because the original tuple, 1, 2, 3, is never changed. It still exists somewhere in memory. We're just pointing the variable name to a new tuple, 1, 2, 3, 4, 5. So technically, tuples remain immutable, but plus equals gives us a convenient way to create a new, extended version of an existing one. Another way to combine tuples is by using the plus operator. In this example, we start with 2 tuples, tuple 1 containing 1, 2, 3, and tuple 2 containing 4, 5. When we use the expression tuple 1 plus tuple 2, Python joins the two together and produces a new tuple, 1, 2, 3, 4, 5. The key point here is that this operation does not modify either of the original tuples. Both tuple 1 and tuple 2 stay exactly the same. Python simply creates a new tuple and assigns it to tuple 3. So concatenation with plus is a safe and simple way to combine tuples while still respecting their immutability. Even though tuples themselves are immutable, we can still use them with lists, which are mutable. In this example, we start with a tuple called my_tuple containing 1, 2, 3, and a list called my_list containing 4, 5. When we use the plus equals operator, Python takes each element of the tuple and adds it to the list one by one. As a result, the list now becomes 4, 5, 1, 2, 3. It's important to notice that this works because the list is changeable, not the tuple. The tuple stays exactly the same, but the list expands to include the tuple's elements. So even though tuples can't be modified, they can still interact with other data structures, like lists, in a flexible way. Here's an example of something that does not work in Python. In this code, we start with a tuple, my_tuple, containing 1, 2, 3. Then we try to use plus equals to add a list 4, 5 to it. But Python won't allow this. You'll get a type error. That's because you can only concatenate a tuple with another tuple, not a tuple with a list. The two data types are different. Tuples are immutable, and lists are mutable. Python doesn't automatically convert one type to the other, so this operation simply fails. Even though tuples themselves are immutable, they can still contain mutable objects inside them. In this example, the tuple, my_tuple, contains 3 elements: a string A, a list 1, 2, 3, and a floating point number 33.33. When we print my_tuple at index 1, we get the list 1, 2, 3. That's the second element of the tuple. Then when we print my_tuple at index 1, 1, we're actually accessing the second item of that list, which is the number 2. This demonstrates that while you can't change the tuple structure, meaning you can't replace or remove elements, you can modify the contents of any mutable objects stored inside it, like lists. So tuples themselves are immutable, but the data they hold might not be. Here, we're not changing the tuple structure. We're changing the second element inside the list that's stored in the tuple. So after this code runs, the list inside the tuple becomes 1, apple, 3. Python makes it really easy to unpack values from a tuple or any sequence into separate variables. In this example, the variable student holds two items, the string Bob and a list, 100, 80, 70. When we write name, comma, grades equals student, Python automatically assigns each value to its corresponding variable. The first item, Bob, is assigned to name, and the second item, the list, 100, 80, 70, is assigned to grades. So when we print name, we'll see Bob, and when we print grades, we'll see 100, 80, 70. This process is called tuple unpacking, or sequence unpacking, and it works with both tuples and lists. Even though parentheses are optional when unpacking, it's a good practice to always use them. It makes your code clearer and helps show that you're intentionally unpacking a tuple. Even though parentheses are optional in both cases, when defining the tuple on line 1 and when unpacking it on line 2, I believe it is good practice to include them. Using parentheses makes your intention explicit and helps others immediately recognize that you are working with tuples. Many developers will argue that omitting the parentheses is the more Pythonic style, that it is cleaner, more concise, and easier to read. And that perspective is common in the Python community. However, I take a slightly different view. Software engineering is rarely an individual activity. We work in teams, and there is no guarantee that every team member comes from a strong Python background. Engineers frequently move between programming languages depending on the project. You might use Python for several months, switch to another language, and then return to Python later. In that kind of environment, explicit code improves clarity and reduces cognitive load. Adding parentheses costs nothing, but it makes your intent immediately clear. In my opinion, making things explicit, especially in collaborative, multi-language environments, is often the better engineering choice. Let's look at how value swapping works in Java first. In this example, we have two variables, number 1 and number 2. We want to exchange their values so that number 1 gets 200 and number 2 gets 100. In Java, this requires a temporary variable. We first store the value of number 1 in temp. Then we assign the value of number 2 to number 1. Finally, we assign the saved value from temp back to number 2. After these three steps, the values are swapped successfully. This is the traditional way of doing it in many programming languages. And as you can see, it takes 3 lines of code just to switch two values. Now compare that to how Python handles the same task. Here we have the same two variables. Number 1 equals 100 and number 2 equals 200. But look at the next line. In a single statement, number 1, comma, number 2 equals number 2, comma, number 1. Python swaps the values instantly. What's happening behind the scenes is tuple unpacking. Python first packs the values on the right side into a tuple, then unpacks them on the left side into the corresponding variables. No temporary variable is needed, and it's much cleaner and easier to read. This is a great example of how Python simplifies things. What takes 3 lines in Java can be done in 1 elegant line in Python. This feature, packing and unpacking, is one of those things that makes Python stand out from most other languages. In many traditional languages like Java or C++, swapping values or unpacking sequences requires extra steps, like using temporary variables. But in Python, this kind of operation is built right into the language. However, to some people, especially those coming from other programming languages, this might look confusing at first. But once you get used to it, it becomes a very natural and powerful tool. And as I always recommend, use parentheses whenever possible. They make your intention clear and improve readability. Tuples might seem simple, but they're incredibly useful in real programs. One common use is returning multiple values from a function. Unlike many other languages that allow only one return value, Python functions can return a tuple, and that lets you send back several pieces of information at once. We'll see examples of that later when we write our own functions. Another important use is using tuples as keys in dictionaries. Because tuples are immutable, they can't be changed. Python allows them to be used as dictionary keys, while lists cannot. We haven't learned about dictionaries yet, but when you do learn about them, you'll find that tuples play a very important role there. Finally, tuples are great for representing fixed data structures, things that shouldn't change, like coordinates on a map, RGB color values, or database records. In all these cases, the data stays constant, so using a tuple makes perfect sense. Sometimes you may need to switch between lists and tuples in your program. Fortunately, Python makes that very easy. In this example, we start with a list called data_list that contains 1, 2, 3. If we want to convert it into a tuple, we simply use the built-in tuple function. Data_tuple equals tuple, open parenthesis, data_list, close parenthesis, converts the list into a tuple. If we ever need to go back to a list, we can use the list function the same way. This flexibility allows you to choose the best data type for each situation. Use a list when you need to change or update data, and use a tuple when you want your data to stay fixed and protected.
Thank you for your attention today. This presentation was prepared by
준비.
with assistance from AI Technologies. I truly appreciate your engagement. See you in our next class.